All right, guys, we're going to move on to transformations, and there's three types: translations, reflections, rotations, which you see below there. But essentially, what a transformation is an operation that maps an original geometric figure. So the original figure we refer to as a pre-image. That's why I put the little pre up there. And then the new image is actually just the image. So image is actually the second figure we're getting. And we're going to do three types. We're going to really look at two of them today, but eventually we'll get to all three. The first one is a translation, which is the simplest one. It's really just moving each point in the same direction and distance of a figure. So if we have 3 points like a triangle, moving all 3 points, same direction and distance. A reflection is always done over a line, and it's flipping it over the line of reflection. So literally we're going to be counting or using some strategies to figure out where the points are on the opposite side of the line of reflection. And then rotation, which we'll get to in our next lesson, is essentially turning or rotating your figure. All transformations, so translations, reflections, rotations, have isometry, which means they create congruent images. This is where they're different than dilations, which is what we did at the end of last chapter with the dilations, because those figures are not congruent, they're similar. With transformations, the figures are similar. So let's take a look at our first type of translation, and it's our first type of transformation, which is a translation. Essentially, this is my first figure, A, B, and C, my pre-image. A is -2, 1, B is -4, -1, C is -1, -2. And you're literally told to move each point up 3 and right 2. And that's what I do. My A goes up 3, right 2. My C goes up 3, right 2. My B goes up 3, right 2. And I record my new triangle and my new points. A prime, which is related to A, but a different point, is 0, 4. B prime, -2, 2. And C prime is 1, 1. So literally that's all we're doing, is we're moving that same distance for all 3 points. If we come down here, I have my original triangle right here, and then the translation is down 5, left 4. I count down 5, I go left 4. I down 5, left 4. Down 5, left 4 for each point. And that's a translation, and that's it. That's really all you need to know about it. Reflections, we're going to go over the easiest reflections today, and those are reflections over the x-axis and the y-axis. And I can give you all the verbiage or the complicated theories or formulas on it, but we're going to go about this the simplest way possible. My pre-image is ABC. A is 0.44, B is 2.2, and C is 5.1. I literally count to the line of reflection, which is the x-axis. So from C, it's 1, 1. And whatever that point is, that's my new point C. It's 5, -1. 1, 2, 3, 4. So I got to go 1, 2, 3, 4. So my A prime becomes 4, -4. My B, 1, 2, 1, 2. So my B prime is 2, -2. We're literally just counting to the line of reflection and counting the same amount on the other side. That's how you do a reflection over the x-axis. The y-axis, we're doing the same thing, but we're going over the y-axis. 1, 2, 1, 2. 1, 2, 3, 4. 1, 2, 3, 4. 1 and 1. And that's our new reflection. So we go from -2, 2 to 2, 2, from -4, -1 to 4, -1, and from -1, -3 to 1, -3. You can probably figure out the pattern in there and use that. But it's probably always easiest to count over the line. All right, guys, good luck with the assignment.